Okay, so let's look at some of the lab here from section D onwards. So the first little bit that we're going to do is to look at Python code that will do our LM hash. So if you remember that LM and NTLM are Windows hashes. Okay, so we'll just start here. Okay, so sometimes the Python code might not import correctly, so we just got to make sure it has the right line breaks. Okay, so we're going to look at both the LM hash and the NTLM hash. Let's give that a run and see what we get. And that's it there. Okay, we'll just prove that that's the right values that we have there. FA and 06, that's right. Okay, so now we're going to try for the word Napier. There we go. Okay, so the next one we're going to do is the APR hashing function. It's quite a slow method, and we can add salt in there too. So the code that we're using is this here. So we're taking a string, and we're also taking as a salt value. Okay. Okay, there's the result there. So you can see the first set of dollars defines the hash value, which is APR1 in this case. The second part identifies the salt. So here, this is the same salt as we've used here. So when the user logs in, we will take their password, so a salt value, and then APR1, and then we'll compute the same. Hopefully we'll compute the same hash value. Okay, so you should be able to just use those ones with the salt. There. Okay, then we'll try some hashing with SHA. In this case, we'll use the crypt function, which should slow down the hashing process. Okay, so we have some salt. we have our string, and we'll print out crypt. Okay, so you see that was slower than the other one that we did there, and within there we see there is a rounds parameter, so that defines the number of rounds that crypt will go through. We can see it here also, and there it's in there. So the 5 identifies that we're using crypt SHA-256, and the 6 there identifies SHA-512. Okay, so if you go ahead and try these once you... The other slow method that we have is bcrypt. So with bcrypt, again, it uses a number of rounds. So we use some arguments here into our Python program to make it easier to run the program. Just create our line breaks again. We need sys because we're using arguments that we pass in from the command line here. There's our password. So that's one argument, and then the second one gives us our salt. Then we'll print out PBK TFS2 for SHA-1. And then for SHA-256. So the first argument is the string, the password we're going to use, and the second one is the salt value. And there you go. Okay, so we can see PBK TFS2, PBK DF2 here. This is the number of rounds by default that we're actually doing. So we see there is 131,000 as a parameter there, and then here is it for our SHA-256. Okay, the salt value that we've used is included there. Okay, so you can try these ones. The third slow method is bcrypt. And this time what we'll do is we'll just try a range of hashing methods. And I need to put in the new lines again. Okay, so there's a salt we're going to be using for all our hashes. Some of them use 2 salts or a longer salt, so we'll just define that one too. so there's MD5, SHA-1, SHA-256, SHA-512. Here's a Linux hash with the crypt for DES. Okay, so this :2 means just 2 characters taken from the salt. And then this one is on a Sun system, MD5. Then we have SHA-1 crypt, SHA-256 crypt, SHA-512 crypt, and then finally bcrypt. So we'll try that. So hopefully you should see at the end. Our bcrypt is in there, and there's the salt value that we've used. We're using 12 rounds, and 2b is the identifier for bcrypt, and we have the hash value defined after that. Okay, so we need 22 characters for our salt value, so we're just parsing that off. Okay, so there's what we had. We had the number of rounds, we had the bcrypt identifier, the salt value is 22 characters, 128 bits from there. Okay, so go ahead and look at the word hello to see what you get. Okay, so that's been a quick introduction to the rest of Lab 3. There's a bit at the end that you might want to try out, where we've got lots of different hashing methods, so just see how you get on with those. And there's a bit where we can use the Hashcat to crack this hash here. Okay, thank you.